However, memory is not a single entity, rather a complex process, and it requires lots of neurosecretory material, if different neuronal ends it secretes, and then it helps to strengthen the memory so we can remember it more and more, or we can forget also. Like, we don't want to keep a sad memory or bad memory, that we can forget, but at the same time we can strengthen our good memories, and then we can retrieve, and that gives us happiness. So to make us happiness, the entire world is looking for happiness. So to do that, happy memories keeps us happy to that. So going to that, the question first came whether memory is defined to a certain location of the brain or it is throughout the brain. So that time there was not much answer because we understand our brain very little. Only like last time Dr. Mahapatra was telling that we understand maybe 20% of our brain, like how the brain functions, because we have billions of neurons, we have billions of astrocytes. They interact with each other, they provide the information, but how it happens? So by neuroanatomically, neuroscientists divided the brain into different lobes like frontal lobe, parietal lobe, occipital lobe, temporal lobe, and limbic lobes. And Broca, one scientist, he found in 1864 that if there is a defect in the frontal region of the frontal cortex, then there are defects in language presentation. That's what he said, that yes, there is a specific region which is important for language presentation. Same time, Wernicke in 1874 also found that there is a region which is Wernicke's region. In that region, if there is a defect, then language cannot be comprehended. So that's what we see. Some people who have stammering problem, they stammer, but they are not frustrated because they don't know what they comprehend. So they don't, it doesn't matter to him or her that what he is or she is processing. But if somebody can comprehend the language but cannot deliver due to the Broca's defect in the Broca's area, then the person gets frustrated. So that time people started to think that there are certain region of the brain. It is not moving. Can you go to the next slide? Multiple. Yeah, so now you can see that there is a concept of phrenology came. So Francis Joseph Gall in the 18th century observed that there are different regions in the brain which are important for different activities like consciousness, mathematical ability, driving skill, emotions. Similarly, memory is located to the certain region in the center of the brain. And that's what it is said, that according to the phrenology, the faculty of memory was believed to be associated with the region of the brain called the origin of memory. So this organ of memory is very important. So I will show you where is that organ and how in that region they process the memory. So the question then lies, that distinct memory center in the brain is there, or it is widely distributed throughout the brain. So to answer these questions, the first few things we have to keep it in our mind, that there are several forms of memory and learning supported by different brain systems. Memory involves encoding, storage, retrieval, and consolidation. Memory imperfections and errors reveal the nature of learning, memory function, and memory crucial role in guiding behavior and future planning. So these are very important to keep it in mind when we are talking about the memory. So that memory, that's what can be divided into different types. Like, human memory, can it be a little bit enlarged? The full screen? So here is a slideshow mode. So human memory can be sensory, and sensory can be of different types: iconic, echoic, and haptic. Whereas there is a short-term memory and there is a long-term memory. Long-term memory can be explicit memory and can be implicit memory. And explicit memory can be declarative memory. Implicit memory is non-declarative memory. And declarative memory can be episodic, semantic, and autobiographical. So now, if I go to each of this memory, again it stopped. I think now people are hearing online. Okay, then you have to keep. So maybe you can stop and I can control. Okay, okay, thank you. Now I can start. It's not changing. Yeah, now it's changing. Yes. So sensory memory, as I say, that it holds information derives from the sense organs that less than a second after an item is perceived. Like, this is iconic, like, through eyes, echoic through ears, and haptic through touch. Whereas sensory short-term memory, there is a capacity for holding small amount of information for duration is estimated to be is a matter of seconds. Whereas long-term memory is from long-term storage. Like you see, I opened my box and closed it. That is a short-term memory. I may keep it or I may not keep it. But you see, I need to take a bus to go to my college. That I remember for every day. That is a long-term memory. I know the bus numbers. So in that way, different types of memories are there. And long-term memory, that types of long-term memories are like explicit memory. That memory is a consciously available. How it is consciously available? Like it is episodic, that memory is a specific event in time and supporting of their information retrieval. For example, someone's name. If I see someone's face, I remember the name, remember the face. Whereas autobiographical, if I have a nice story with my friends to share, that is autobiographical. Whereas semantic, that is a knowledge about the formation, that is the like words. I am formulating some words, that is semantic. Whereas implicit, it is unconsciously happened. Like some of you already know, and you will know that Pavlov did an experiment. When Sir Pavlov used to give food to the dog, he used to ring a bell. And when he used to ring a bell, the saliva used to be secreted from the mouth of the dog. But later, after a few days, he didn't give food, but he only rang the bell. So the dog heard that through its ears and can respond to that. Even there is no food, the saliva was secreted. So that is an implicit memory. So these are the types of long-term memory. And the memory now, like different region of the brain, as I mentioned, that in the brain, there are different regions which are responsible for different types of memories. So from a neuroanatomic distribution, amygdala is emotional and episodic memory. Like see, if I see a movie which is very romantic, I keep it in my memory, I get happy. At the same time, there is a very sad story, tears comes on my mind. whenever this movie goes, the tears will come. So this is called emotional and episodic memory. And hippocampus keeps the declarative memory, cerebellum keeps the procedural memory, and that is entorhinal cortex keeps the episodic and semantic memory, and basal ganglia keeps the procedural memory. So as they have defined regions, amygdala, entorhinal cortex, cerebellum, hippocampus, my talk will be mainly focusing on hippocampal region, that because hippocampus is one of the important region where all the information comes and memory is processed. So let us see where is the hippocampus. So hippocampus is located deep within the temporal lobe. As I said, we have frontal lobe, parietal lobe, occipital lobe, temporal lobe, and limbic lobe. So it is deep within the temporal lobe. You can see it here, and you can see this is a paired organ, and parts of the limbic system also associated, because when limbic system is damaged, memory also gets hampered. That's what limbic system is also associated. And the paired organ looks like the seahorse. The name of the seahorse is called hippocampus. That's what the name was given. The region is hippocampus. So function includes formation of the new memories, memory consolidation, and spatial navigation. So now here you can see that different types of memories will be formed, but they will come from different sense organs. Like you can see here, the visual information, the color of the dress, facial expression will go through the visual cortex, and then somatosensory cortex, cold temperature, then auditory cortex, that olfactory information, smell of the food, and auditory cortex, the persons can sing. All these informations, you can see they will be going to the hippocampal, the paired region, and will be processed. And that's what hippocampus is, the region where memory can be processed and consolidated. And here, if I take into further, you can see this is actually step 2, the memory consolidation happens. In memory consolidation, there are short-term memory, which goes for long-term memory. So strength of the neural connections are very important here. Like some people can ask the question, how memory is stored? So you can see when neuron gets fired, neuron secretes some neurosecretory materials, and they actually helps to form the short-term memory. And then recalling and remembering, as they recall more and more and they remember more and more, it goes to long-term memory. So what happens? The neurosecretory materials will come and they will bind to the postsynaptic density region receptors, and they will be converted to long-term memory. So short-term memory is a part of presynaptic neuron, and long-term memory is a connection between short-term memory and the postsynaptic density region. So long-term memory actually goes for postsynaptic synaptic plasticity. So what happens when the neurosecretory material comes? These neurosecretory materials, they are coming due to the neuron firing. They are released from the neurosecretory vesicles, and when they come, they will bind to the postsynaptic density region, and new proteins will be synthesized, and new connections will be formed, and that gives the long-term potentiation. But if, say, short-term memory is here, but they do not need to keep it in long-term memory, then it will be withdrawn. That is called long-term depression, or long-term potential, opposite to long-term potentiation. So synaptic plasticity will happen, and here you can see that will form the more and more neuronal connection, and that is basically the formation of the neuronal network. So now in the neuronal network, how it forms? So this is the parahippocampal gyrus. You can see here from the entorhinal cortex, they will go to the mossy fiber to the dentate gyrus. From the dentate gyrus, they will go as a bundle to the CA1 and CA3 neurons. From CA3 neurons, they will come to CA1 neurons, and they will form to the subiculum, and then it will be processed. So hippocampus formation is involved into trisynaptic circuits. So long-term potentiation, how it happens, I will give an example of glutamatergic neurons of the hippocampus. So you can see here, this is neuron is fired and the neurosecretory vesicles are secreting neurosecretory materials. They are binding to the AMPA receptor, and due to the AMPA receptor, there is a, like sodium is coming in, there is a small depolarization current is formed. But what will happen that if there is a strong or repeated signals are coming, then they will finish binding to the sodium, and sodium will come in, and as there are more sodium, they will bind to the magnesium due to the positive polarity, and then the magnesium will open, then there will be channel is opened and more sodium will come in, calcium will come in, and they will give the long-term potentiation. So what will happen in the postsynaptic resting area, AMPA receptors actually is involved. There is a PKC formation or CAM kinase 1, whereas in long-term potentiation, there is a NF-kappa B and there are CERB is there. So this CERB is a transcription factor which binds there, and it amplifies the signal, and the signal will form the long-term potentiation. So now this is about the memory formation in the hippocampal region and memory, how it is processed. That's what all the informations will be there in the memory region, in the hippocampal region, and it will be consolidated. You heard from several lectures, like, you know, that in some diseases, memory gets lost, memory losing disease. And you will hear from me some of the neurological disease where memory is not a direct effect. But due to that disease, there is a memory loss can happen, like Alzheimer's, Parkinson's, multiple sclerosis. But before that, I want to tell you that how memory can be affected, because memory, when they form, they can also be affected due to our health condition. So what are the factors? These factors are, you can see there can be intrinsic factors, which are age, maturity, medical conditions, emotional factors, and there is a rest and sleep. These are intrinsic factors, and there are some extrinsic factors. Among these extrinsic factors, there are like meaningful materials, and about the materials, and there is a, like, you know, discrimination, there is a strong activity, and there is a impaired activity also. So these are extrinsic factors, like, you know, when it comes from the outside, and this will come from the inside. So brain has, any neurodegenerative disease has two types. One is cell autonomous, one is cell non-autonomous. What happens in cell autonomous? Like some factors which are present within the cell, and that factors actually causes the disease, that is called that cell autonomous. You know, like, you know, some of the proteins like A beta peptide, alpha synuclein, these are CAG repeats, these are neurons' intrinsic properties, but these intrinsic properties can get affected due to some disease, and that time it is called cell autonomous. But if there is a viral challenge or there is a trauma, then this is called non-autonomous. So we will be mainly talking about the cell autonomous, and my talk will be mainly focused on the medical condition, like when the memory get affected. So here I can show you that progressive loss of the structure of the function of neurons ultimately causes cell death. And if there is a neuronal cell body gets affected, then this is called neurodegenerative disease. But if cell body is intact, but there are alteration in the other parts, like, you know, axon gets damaged or myelin gets damaged, this is called neurological disease. Examples are amyotrophic lateral sclerosis, multiple sclerosis, Parkinson disease, Alzheimer's disease, Huntington disease, multiple sclerosis, and multiple system atrophy, as well as prion diseases. And to make a note that specifically, like none of the specifically on memory, instead memory loss is often a causative of generalized neuronal dysfunction. If there is a generalized neuronal dysfunction, then memory loss can happen. The billions of neurons which are connected, they actually get lost, or there is a death, and that affects the memory. So I will be mainly talking about Alzheimer's disease, Parkinson's disease, and multiple sclerosis. And multiple sclerosis, I work in an experimental mouse model which mimics certain pathology of human neurological disease, multiple sclerosis. So you will hear from me about the experimental animal model also, where we do not study as such memory, but we try to understand what happens when virus enters into the brain and how it affects the neuronal circuits, how it affects, causes the neuronal death, astroglial death, and that can affect memory. So first, let me dissect out what is Alzheimer's disease. So Alzheimer's disease, you know, in our brain, there is a protein, it's called A beta peptide, which is very much important for neuronal repair. And that protein has a normal function. In normal brain, what happens? There is a alpha secretase and gamma secretase. They cleave the protein into, and that forms the soluble degraded protein. And this protein is important for neuronal health. But, you know, in normal condition, that's happened. But in diseased condition, there is another one, that is the beta secretase. When beta secretase come, this enzyme cleaves the protein in different regions and can cause insoluble aggregates. And when this protein gets aggregated, they form the neuronal plaque. And this plaque formation is abnormal to neuron. So now you can see in between the neuron, there is a plaque formation. And this plaque formation actually causes the disruption of the microtubules. So in a normal healthy brain, the microtubules are aligned properly through the axon. But here what happens? Through the axon and the neurofilament, the neurofibrillary plaques, plaques comes, and these plaques causes alteration of the transport of the tau protein, which is also another protein involved in the microtubule associated protein. This protein gets degraded, actually it gets hyperphosphorylated, and then they form the tangle. So there is a plaque formation, and plaque formation actually induces the hyperphosphorylation of tau protein, which forms tangles. And these plaques and tangles starts to form the entorhinal cortex and hippocampal formations, and later spreading into the other temporal, parietal, and finally frontal association cortex. That's what memory loss happens. So what happens? Plaque disrupt communication between brain cells and interfere with the normal functioning of the neural network. So they come in between, and the normal network, like, you know, the action potential comes and they goes to the synaptic terminal. The neurosecretory material secreted. The neurosecretory materials helps to bind to the postsynaptic density region. But as plaque is formed, these neurosecretory materials may be secreted, but cannot bind to the postsynaptic density region. That's what the plaque actually causes, discontinuous action potential propagation. And that's what this plaque disrupt communication between brain cells and interfere with normal functioning of the neural network. Whereas tau protein becomes tangled and impair the transport of nutrients and other essential substances within the cells, and that actually contribute to memory loss and cognitive decline. And there is a disruption of the levels of the neurotransmission. So you can see here, as I mentioned, the plaque is formed here, neurofibrillary tangle is formed there, so they cannot propagate the action potential properly. If action potential is not propagated at the nerve end, they cannot release the neurosecretory materials at the nerve end. Even they secrete it, if there is a plaque, they cannot bind to the postsynaptic density region, and in that case, the no nerve impulse can be transmitted, and that like actually reflected in the memory, and that is basically acetylcholinergic nerve causes this type of plaque formation and memory loss. So what happens? There is Alzheimer's disease. When the plaque is formed, there is a mitochondrial dysfunction and inflammation happens. Of course, there is the accumulation of the foreign protein, not foreign protein, Alzheimer A beta peptide is aggregated, and that forms inflammation, and there is a oxidative stress. Due to age also, oxidative stress can happen. That's what you can see nowadays. A large number of people get Alzheimer's, and it is a very much warning, like that we get lots of age due to medication, like people live more than 80, 85, 90. But if you see during our independence time, the average age limit was 45. So people was never showed any neurological problem, or they didn't show like Alzheimer, memory loss. But nowadays, lots of people develop this disease, and it is really alarming. So we have to be careful, like, we have to do our exercise. We have to keep doing eating healthy food, so there is no oxidative stress is developed, because oxidative stress, if it is developed, build up, it's believed to play a role in the progression of the disease and contribute to the memory loss in Alzheimer's. And a significant loss happens due to sympathetic connection leads to breakdown of communication between brain cells, as you can see, between two neurons, and astrocytes are in the periphery of these neurons. Astrocytes helps in mopping the neurosecretory materials, but that time astrocytes cannot function also, and this disruption disrupt memory consolidation and material retrieval process. So there the end process is memory loss. So that is basically about the Alzheimer's disease, how it impacted the memory formation. Then there is another disease, which is Parkinson's disease. You might have seen like some older people develop that, and actually it starts from age 55, then it goes to develop more and more, and people have tremor, people cannot, their limbs like cannot function properly. So that happens due to dopaminergic neurons in the substantia nigra generally die, and that gives the disease. So what happens, the main job of the basal ganglia is to coordinate movement. And how they coordinate movement? By direct pathway or by indirect pathway from the striatum to globus pallidus and subthalamic nuclei and substantia nigra. So they uses excitatory neuron. They also uses inhibitory neurons, and the interaction between excitatory neurons and inhibitory neurons help people to move, or there are no movement. So slowly this gets degenerated because there is the accumulation of a protein, which is alpha-synuclein. When alpha-synuclein aggregates in the substantia nigra, then the connection is lost, and that time it forms the tremor. So let us see in direct pathway what happens. The motor cortex gives the excitatory signal to striatum. Striatum gives inhibitory signal to globus pallidus internus and substantia nigra. And substantia nigra cannot give any more signal, so it is a negative signal to thalamus. But instead of negative signal, thalamus provides the positive signal to the motor cortex, and the end effect is movement. But in indirect pathway, what happens? Motor cortex gives excitatory signal to striatum, but striatum gives inhibitory signal to globus pallidus externus and subthalamic nuclei, whereas all through there is a negative signal, but this negative signal comes as a positive signal to thalamus, but motor cortex cannot help to move. So there is no movement. So generally what happens? Substantia nigra, dopamine is secreted. Dopamine gives the excitatory signal to striatum, and stimulates direct pathway and inhibits indirect pathway. That's what, due to the inhibition of indirect pathway and excitation of the excitatory pathway, like they move. So that's what you can see in Parkinson disease. People slowly have some problem in external extreme organs, and slowly they go to cane, then they go to that chairs, and then they go to wheelchairs. So what happens here? Dopaminergic neuron in the substantia nigra gradually die, and less stimulation of the direct pathway and more stimulation of the indirect pathway, and overall reflection is that is reduction of the movement. That's what happens in Parkinson disease. But from the cellular aspect, if we look at it, what happens at the cellular level? In the substantia nigra, there is a protein called alpha-synuclein. This alpha-synucleins gets aggregated and they form the Lewy body inside the neuron, and Lewy body formation causes inhibition of the excitatory signal to go through, and together they do not allow neuron to communicate to each other. And as an effect, what we see, tremor, stiffness, difficulty in walking, cognition and memory loss. These are the effect of Parkinsonian disease. And Parkinsonian disease has a cognitive impairment also. This Lewy body, as I said, alpha-synuclein can affect multiple brain regions involved in memory, including the hippocampus, which is crucial for formation and consolidation of memory that we already dissected out. And Lewy body is in substantia nigra, that can be stained, and you can see this is brown color is the Lewy body, and this Lewy body can affect multiple brain regions. And it function reduction of dopamine level. So L-dopa comes, L-dopa goes to dopamine, but if there is a restriction in here, that L-dopa cannot convert it to dopamine. So reduction of dopamine level in the brain can contribute to memory impairment, and that affect memory process, including emotion consolidation and retrieval of encoding, the consolidation and retrieval of information. And as a cause, what happens? That is a PD may import the medication of the PDs also. Like when people take the medication for Parkinson disease, there are lots of side effects. One of the side effects is memory loss due to the lack of dopamine. So while this is about Alzheimer's disease and the Parkinson disease, multiple sclerosis is one of the neurological disease. It is a big question whether we will add it as a neurodegenerative disease or we will keep them in neurological disease, because depending on the etiology, how the disease is caused and what are the factors, it can be classified as neurodegenerative disease, but in most of the cases, we call them as neurological disease. What happens? It is one of the main disease, neurodegenerative inflammatory autoimmune disease, predominantly white matter disease of the CNS, including brain, spinal cord, and optic nerves. And myelin sheath degenerates, causing demyelination, adds impedance to nerve impulse in process. So what happened, the neuron has a cell body, a neuron has axon. The axon in most of the motor neurons, axon is myelinated. What is there? There is a cholesterol and there are lipids. They actually, proteolipid protein forms a wrapper around the axon. For that, what happens? The sodium channel is aggregated in the nodes of Ranvier. And for that reason, where electrical impulse can jump from one node to another node, and now impulse can go faster. That's what it is called, saltatory conduction. And for these saltatory conductions, the nerve impulse, if a mosquito come and the mosquito touch the fingertips and immediately we slap, like how this happens within a fraction of second, because due to the myelinated nerve fiber. But in some in multiple sclerosis, this myelin sheath gets degenerated and normal impulse cannot be propagated. And that has different cognitive functions, then visual effects, then there is a mechanical effects, sensory information is lost, bladder function is lost, and there is a urinary bladder function also get lost. So there is a pain. So all these are associated disease symptoms. And in MS lesion, there are different things are happening chronologically. First, what happens? MS lesion can occur in different areas of the brain, including region associated with memory. But generally, nerve fiber accumulated in the white matter. They form the white matter tract. And in the white matter tract, they generally go from one neuron to another neuron in a saltatory conduction, like corpus callosum, deep cerebellar white matter, optic nerve. These are myelinated nerve fibers. And in these myelinated nerve fibers, nerve impulse goes faster. So in this one, actually, sorry. Yeah, MS lesion that's occur in different areas of the brain, including the hippocampal region where memory and cognition is there, and there are areas affected. It can lead to memory deficits. And disruption of neuronal flow due to the lesions can interfere with the encoding, consolidation, and retrieval of information, resulting in memory problems. Chronic inflammation in the brain happens due to the inflammatory responses, pro-inflammatory and anti-inflammatory milieu has developed due to the CD4 T cell attacks, and there is a cognitive impairment inducing memory loss by damaging neurons, and there is a neurodegeneration which is including the loss of brain tissues or contribute to cognitive decline and memory. And other factors like fatigue, mood disorder, these also together can make the person to go to wheelchair. So though the multiple sclerosis is not a life-threatening process, it doesn't kill people, but it has a huge socioeconomic impact. People develop chronic demyelination and chronic axonal loss, which helps people to go for wheelchair. So what are the etiology of how it happens? There are several etiology. There can be pathogens, which is like protozoans, viruses like herpes virus, varicella zoster virus, cytomegalovirus, Epstein-Barr virus, JC virus, and human endogenous virus. That there are bacteria also, Chlamydomonas, Mycoplasma, Spirochete, all these bacteria is also listed, and other factors like sunlight, vitamin D, smoking, obesity, gut microbiota. And there is a large school beliefs that there is a autoimmunity. What happens? Body develops its CD4 T cell, and these CD4 T cells attack the myelin. This CD4 T cell are against the myelin protein, and they attack myelin, and that's what myelin sheath gets degenerated. When myelin sheath gets degenerated, then axon gets denuded, and that causes the demyelination. Okay, so this is the etiology, and it is very difficult to study multiple sclerosis in human being because it is episodic, and it is like goes for relapsing remitting mode. That's what we trust in animal model, and we study in animal model experimental autoimmune encephalomyelitis, where proteolipid protein can induce multiple sclerosis type disease. Myelin oligodendrocytic glycoprotein can also induce multiple sclerosis like disease, and MP4 is another myelin associated protein which can also causes the demyelination. Whereas toxin induced model, there is a cuprizone induced model or lysolecithin, and viral induced model is chiral murine encephalitis virus, mouse hepatitis virus, Sinbid virus, and Selmicki forest virus. These viruses can cause the demyelination, which mimics certain pathology of human neurological disease, multiple sclerosis. How much time I have? Okay, so my lab works in mouse hepatitis virus. Due to time constraints, I am not going to discuss much, but I just want to tell that the virus, when it comes, it causes meningitis, encephalitis, and myelitis, and in chronic stage, it causes demyelination, which is like human neurological disease, multiple sclerosis. So it is a unique model to study the viral induced demyelination. And this virus also belongs to the same group, same coronavirus family and genus beta coronavirus like SARS-CoV-2. So at one hand, it gives the disease process which mimics multiple sclerosis, but SARS patient also, there are lots of neurological deficits. So by using this model, we can try to understand what is happening in SARS-CoV-2 affected patients. So here I'll skip it. This is the main thing, like, you know, we use different knockout mice, and from molecular interaction point, we come to a point CD40 ligand and CD40. We use that knockout mice, and we showed that CD4 T cells express CD40 ligand, plays a protective role in virus-induced neuroinflammatory demyelination, and microglia macrophage express CD40 is also providing impactful results in CD40. So the molecular mechanisms between the dyad between CD40 and CD40 ligand is mainly responsible for developing the disease process. So at one hand, we can study in human, but in human, we don't know how it is happening at molecular level. So in our experimental animal model, by taking the example from the mouse hepatitis virus, we came to a point that CD40, which is expressed in the microglia macrophage, and its interaction with CD40 ligand, which is expressed at the T cell, are mainly responsible. So microglia and microglia macrophage and T cell are mainly responsible. So that's what we can conclude, that absence of immune checkpoints regulated protein, if we can control that, then there is a reactive oxygen species, there is a progression, and then there is a immune cells. They causes heightened neuroinflammation and degeneration of the neurons involved in memory function. These are together forms the cognitive impairment and memory loss. So this, in conclusion, I can say memory is a complex cognitive function that involves the encoding, storage, and retrieval of formation. Memory is not a single unitary function, and it's insufficient for multiple factors, influenced by multiple factors. Memory is subjected to forgetting and distortion. Memory abilities can vary among individuals due to genetic, environmental, and experimental factors. And memory can be improved and optimized. Memory can change, can occur with age and certain condition. So we all have different types of memory. So we can work towards developing the memory more and more by practicing. That's what, when we teach in a class or when we give a talk, we tell people to be attentive, to understand what is going on. Otherwise, if you don't develop this neuronal connection, it won't be in the memory. Like, you heard the lecture for 1 hour, but if you don't hear, if you hear, that will be like, you know, iconic, and then they will go and they will develop the memory, and that will be formulated in the hippocampal region, and that will remain for longer time. So that is basically stimulus, sensory memory, short-term memory, and long-term memory. And that is neuronal connection. Depending on that, we have different mental ability. And due to time constraints, I'm not going to discuss much about it, but my lab at IISER Kolkata works on neuroimmune modulation, as I discussed a little bit, structure function analysis of the spike protein, antiviral therapeutics, like by using Nimbuk extract, and genomic control of pathogenic properties, host cell response, and cell-cell communication. And we also have a part, as I have long-term experience in developing animal model, I was bestowed with a big grant to develop the cancer models. So I have developed ovarian cancer and cervical cancer model in my lab. So the students are here. If you are interested to do intern, or if you are interested to pursue your work in neuroinflammation and cancer biology, you are most welcome to contact me. And with that, my sincere thanks goes to the entire lab group. I have 13 PhD students who graduated already, and they are now in different parts of the world pursuing their postdoctoral work and their job. And now I have 15 PhD students who significantly contributed in the work what I presented. And my student, Mr. Vishal Hajra, is here, who helped me to build the talk and also designing the PowerPoint presentation. And I'm thankful to a good group of people I am working with, Dr. Ganesan at Cleveland Clinic, Dr. Cornelia Bergman from Cleveland Clinic, Dr. Maria Nagel from University of Colorado, Ravi Mahalingam from University of Colorado, Dr. Kenneth Schindler from University of Pennsylvania, Dr. Michael Koval from Emory University, Dr. David Bloom from University of Florida, and Dr. Ujjwal Niyogi from the Karolinska Institutes. We have a good group of people working together in the US Science and Technology Forum. You can see here IUSSTF grant, and I have collaborated in India, Dr. Devnath Pal from IISc, Dr. Arup Banerjee from RCB, Faridabad, and Dr. Vidisha Sinha from IISER Kolkata. I'm thankful to the funding body, IISER Kolkata, CSIR, IUSSTF, CRB, that ASM, American Society for Microbiology, High Media, Department of Biotechnology, and National Multiple Sclerosis Society, USA. And thank you all for your patience. Any question?
Hello. Yeah, you can ask questions to Madam if you have.
Thank you for your talk. So I had a question that currently many anti-amyloid drugs have been tried, and some of them did not have such a good result as expected. And now people are exploring other alternative hypotheses than the one which has the prime role in driving Alzheimer's research, like the amyloid beta plaque hypothesis. So can you comment on the alternative hypothesis?
Like, now initially people tried to see if they can stop the work of the beta secretase. So that's what most of the drugs were designed, which can work to stop the activity of beta secretase. But now people are working on how to dissociate the plaques. So now in silico approaches they are taking to see if they can dissociate the plaques. In that way, the soluble products can be dissociated. So that's what work is going on. But so far, these are such a process. The neuron, as I mentioned, it's a very complex organ. Brain is a very complex organ. And within that plaque, to dissolve it, it's not that easy.
Ma'am, if somehow we transplant the brain, then how memory can be affected?
Transplant the brain.
Yes, ma'am.
It's a very good.
Not brain.
Yeah.
Embryonic neuronal stem cell.
Yeah.
It's not brain. It's not a brain from brain.
So embryonic stem cell, it has a pluripotency. Like pluripotency means embryonic stem cell can be differentiated into different types of cells. So if the hippocampal cells CA1, CA3 can be generated, then memory can be stored also. And in that way, people are trying to do it. But embryonic stem cell to transplant to put the memory, because this is part of the development also, neurodevelopment when it happens. Hippocampal is very much hidden and within the temporal and the limbic lobe. So to get access to there and provide the neuronal stem cell is a big challenge. But it's a like thought is going on. Hopefully one day people will be able to do that.
We did a neural transplant project of Alzheimer and DHP from 1980 to 1990, about 90 lakh project. So we are taking the brain of the embryonic brain from the rat embryo and putting in the brain of the adult rat. What we are doing, monkey and rat, we damage the substantial nigra by stereotaxically and put embryonic brain to see whether that brain tissue which is taken from embryo produce the dopamine or not. But what we did subsequently, when we did immunohistochemistry, chemical studies, we did not see that the tissue which was transplanted were producing dopamine, but it was not reducing the disease. So aim was to see whether the neural stem cell put in the diseased human being not only produce neuron, secret chemicals, also get desirable result. But desirable result was not coming. There are some people in Stockholm, they are doing the human being stem cell taken from the bone marrow, put in the Parkinson patient to see that whether bone marrow stem cells converted to a dopaminergic neuron, but that project which was started 90s and 2000s also did not work. So currently we do not have stem cell therapy except bone marrow transplant. So if you get chemotherapy, bone marrow is suppressed, to take a bone marrow either from same individual, from somebody else, put in the another same person disease, the bone marrow taken up. So bone marrow transplant has become reality. But if you're thinking like a liver transplant, brain transplant, that you know, you have to cut somebody's brain. And so liver transplant we have to do, take a liver from a normal person, that is half of the liver, left lobe, small lobe, put to the person who is having liver disease, retaining the major part of the liver for the donor so that he doesn't die after giving part of the liver. We have seen donor also dies after the giving liver. So once who take our transplant from a normal, now we have to talk about cadaver transplant. That started in India in 1994. We took the kidneys and liver from the brain dead patient, which are, see that what is brain dead, what is physical death. Brain death is brain stop functioning, heart function, kidney function, muscle function, but brain stop functioning. So if you go to American Association of Transplant, 1966, they started talking how to take from the man who's dying. Somebody dying in an accident, he's put in ventilator, his body is not functioning, brain is not functioning, but the physiologically heart and kidney is working, lungs is not working, brain is not working, nothing. That is what we call cadaver organ transplant. So a person is brain dead, you take out the organ, liver, kidney, spleen, bone marrow, bone, all these kind of transplant to another person. Go to website, see the transplants in India.
Thank you, Professor Das. I'm very much thankful for your lecture, which has a lot of clarity and accuracy in data. This is the significance of this lecture. I have no question, but I have little bit of clarity. Can you go to the slide in which you are classifying the types of memory? Classification of type of memory.
Types.
Little bit back. This is from beginning, I think. First 3 slides, I think.
Yeah. Take some time.
Yeah.
This one?
Just next. No. Little backward. Go back. Another 2 slides. Okay, just I am asking about clarity. Okay, clarity. In that slide, you are saying explicit meaning, explicit memory is declarative memory.
Yes.
Why it is declarative, not directive?
It is like, say, you had a nice visit to your friend's place. You had lots of memory in that time. Okay, and then you are, after 1 year, that day is coming. Then you can remember those days, you remember those things, what happened in your friend's house. That's what it is declared. It is a fact associated. That's what it is declarative. But non-declarative is, even if you give like input or not, it will automatically.
Okay, thank you.
Thank you very much, madam. It was very technically filled. Those who are not from the field, it is a little overwhelming. No, there is spirituality will, will come. One question I have is that the short-term memory, sensory input, it is very not useful little later, so we understand. But other memories, under what circumstances they become long-term memory? What kind of short memories they become long-term memory?
So the short-term memory, when there is a repeated exposure, like repeatedly, like say you are reading a poem, you are reading more and more and more, and then it will go there. So what will happen? Neurosecretory materials will be secreted. They will bind to the AMPA receptors. AMPA receptors will allow short depolarization current. That is short term, but the moment you will repeat it more neurosecretory signal will come. More sodium will get in, more positive signal, magnesium will be displaced, and then NMDA receptor will be activated, and that will create more and more synaptic density region, that more synaptic connection will be developed and you will remember that.
Thank you. The basic idea is repetition. When you do something repeatedly, it will become long-term memory. So please note it. Do good things more often and unwanted things less frequent. And number 2 question. Number of factors that influence the disease, viral, microbial, and other very delicate things. Diagnosis appears to be a little challenging because by the time the patient, he may think, oh, I have a little headache or something, he may not realize. Even if you go to a doctor, he may not immediately realize. So it may be very late by the time the diagnosis itself is done. So what is the current status? Is it
CNS diseases, like especially I can talk about multiple sclerosis as I work in that. The name is multiple sclerosis. There is a multiple region is affected and there is a multiple etiology. So, like even people believe it is autoimmune disorder. CD4 T cell attacks the myelin and cause the myelin degeneration, then axon gets diseased. But in certain region of the brain, T cell cannot reach that region, how it is affected. Then people thought that viral infection is involved. So it is true, like, it is very difficult etiology-wise to understand. That's what for multiple sclerosis, generally people give the anti-interferons, but that doesn't work very well in some patients. So it is a challenge, and I think it depends on luck and God's grace.
I have just one comment. Lot of students will come, parents will come during exam and say he is not able to retain, he is forgetting, and his performance is not good. So what I tell them, first take relax. If you relax, because the tension mind will have a temporary memory loss. When you go to exam, should be free and peaceful mind. So before 1 or 2 days exam, don't read up to p.m. Sleep 6 to 8 hours. So temporary memory loss could be distress, anger, sleepless nights. So a lot of people, student will tell, I'm forgetting. But that you should avoid. Sometimes people say reactive. Because the question is that in a tension mind, stressful mind, angry or agitated mind, negative frame of the mindset, you will not be able to deliver. So for the students, you should keep calm, sleep well, have good food, have good oxygen, breathe all right, if possible do pranayam, so that whatever little you read before exam, you remember. Second question, what people ask, I am forgetting any allopathy medicine. I say there is nothing called allopathy medicine, but what we know from Ayurveda, Brahmi, Ashwagandha, Ola, aloe vera. These are the things, very ancient time. We know that these things either improve memory or prevent memory loss. Do you think that? I don't think any of the CDRI or any research laboratory works on temporary memory loss in animal, in a experimental animal, and give this Ola, aloe vera, or Brahmi and see whether the rat, that maze walking test, very simple test. Right? Rat has lost the path to go, but feed them with Brahmi. What happened to them? Because these are the experiment, that is what we do. I especially tell all the students take some Brahmi tablet, and don't resort to too much of non-veg, excitation, depression, sleeping 3 a.m., getting at 5 a.m. Today somebody told me he sleeps at 2 a.m. and get up 5 a.m. So what will happen if you sleep for 3 hours? Your mind will not get rest. You will not, physical body, mental state, psychological state will be all in stressful situation. In stressful situation, you like to forget. I think a lot of students are there. I have never read in my life after 9 o'clock, 9 p.m. I always get up at 3, 4 early. Today morning I got up 3:30. So why sleep in the late night? You have any comment on Brahmi?
Yeah, of
or
course, this
Ginkwari?
has the good effect.
We all
but
take it. You take
the
it?
in animal model, the problem is mode of delivery.
Swamiji, all they take is Brahmi, all this. But these people, students don't believe all this ancient medicine, Ayurveda. Anybody, any children, a child, college, university, do you take aloe vera, ola, Brahmi? No. वो तो दादा दादी का फूड है. Absolutely. I think they don't believe in this, but Ayurveda has a lot of things.
Yeah, Ayurveda has lot to do in memory.
Thank you so much, ma'am. I think her speech was wonderful and it has excited a lot of queries from the audience. I would like to convey my many thanks to Professor Jayasri Das for sharing her vast knowledge on memory and various brain diseases in humans. I'm sure all of us learned a great deal from her presentation. It was a very beautiful presentation. Thank you so much, ma'am.